Hello! In this video we will have an in-depth look at the RED IPP2 pipeline within Baselight. IPP2 stands for Image Processing Pipeline 2. It's RED's current pipeline to transfer raw sensor data to a final image on the display. IPP2 consists of two components within Baselight: the raw decoding and the display rendering transform, short DRT. The DRT is not shipped with Baselight, but is available as an additional download from our webpage. Go to the support section and latest downloads, then select TrueLight Color Spaces, RED IPP2. Here you can find a zip file to download. On a Linux system, unzip it into USR FL etc color spaces, and on my Mac here I unzipped it into Library, Application Support, Film Light, etc. color spaces. Okay, let's create a scene in Baselight. I give it a name. I select No Scene Template in this occasion. I suggest you create your own IPP2 template after we're done with this tutorial. I set the working format to Ultra HD, working frame rate to 24p, and the working color space to red log 3G10, red white gamut RGB. Now I need to go to the scene settings in the views menu. Go to format and color and change the display rendering transform from TrueLight Cam to RED IPP2. Note that the IPP2 DRT supports a couple of different viewing conditions. This is what we call a DRT family, so it is compatible with SDR and HDR workflows. Let's drop some footage into the scene. I go to Flux Manage and select a red clip. Note that here in Flux Manage you can see some basic metadata of the footage, like the camera model or the camera firmware. And I hit Insert Sequence at Cursor. I set my container path, and here is the clip in the timeline. Okay. Let's duplicate that clip and turn off Baselight's color management system, TrueLight Color Spaces. I select a manual color space instead of automatic for input. The working color space of the shot I also set to 2.4 gamma 709. Then I adjust the IPP2 parameters to medium and medium, and the output tone curve to Rec 1886 and the color primaries to 709. If we examine the color space journey, we will see that no color space conversions are now happening within Baselight. Everything is performed by the RED SDK on the raw file directly. If we compare this output to the fully color managed output of Baselight, going from RED linear to Rec 1886, we see the result is identical. The important thing is that the input color space should always match from the tone curve and the color primaries to the output tone curve and the output color primaries of the RED SDK. So if we want to do a scene referred workflow but not use the automatic decoding for whatever reason, I can choose here log 3G10 for the tone curve, red white gamut RGB for the color primaries, and here for the input I select the according color space from the menu. As a working color space, in this case I should also select a scene referred one. Here I choose the same red log 3G10, red white gamut RGB. Again, we can see the result is identical to the automatic decode from Baselight. When we examine that shot here in more detail, we notice a few colored fringes here at the fine edges. Is this a problem of the footage? No. What is happening is that Baselight is decoding an 8K resolution RAW file to an output resolution of Ultra HD currently, and it's in optimized resolution mode. That means Baselight is not decoding the RAW at the full resolution because it thinks it's not necessary to optimize the performance for the grading session. If you want to see the maximum quality decode, we should set our cursor to max quality, and you will see that the colored fringes disappear. You can also force raw footage to always decode at max quality with that switch here, then this clip will always be decoded at max quality. In this case, it also makes sense to strip cache the input so that the performance during the grading session will be much better. Let's have a look at the raw decoding settings now. Here, the input clip is set to automatic. This is what we recommend for all raw clips coming in. Then Baselight will set all the raw parameters to best practice so that it can extract the most dynamic range and color fidelity out of the files. You will notice that a few of the parameters are now locked because Baselight is protecting them to maintain the best quality decode. Here in exposure also a few ones are locked. To illustrate this, I have another example. Here we have a shot that I intentionally set to a very bright decode to ISO 12800, and here we're decoding it with automatic settings. And there is a shot where we decoded the same shot to red log film, red color 2. Here I set the input color space accordingly to red log film, red color 2. If I'm now trying to rescue that shot by stopping it down 6 stops with base grade, we can see that in the automatic decode we have no problem, but in the red log film decode we have clipped highlights because these extreme decoding settings cannot be maintained by the red log film tone curve. Generally, it's always good to decode with automatic input settings because then we're using floating point operations that do not clip. Here we have a raw clip inserted to the timeline twice again. First in automatic mode with the scene referred color managed pipeline, and the other one skipping all the color management within Baselight. Let's examine a few different parameters in the raw settings. You will notice that in automatic mode a couple of raw parameters are locked from being edited by the user. Also in the IPP2 panel, the parameters for the highlight runoff, the tone map, and the HDR peak nits. This is because these parameters are only used if we convert to display referred color spaces, because these are parameters of the red IPP2 DRT, not really raw decoding settings. So if we would apply these parameters, we would not be able to grade in a scene referred color space anymore. That's why we're locking them. In the IPP2 DRT that you can download from the web page, we use the parameters of the DRT medium and medium for highlight roll-off and tone map. These parameters are not intended to be changed on a per shot basis, but more as an overall preset for the whole project. What if you want to adjust these parameters in Baselight in a scene referred pipeline? There's no automatic way to do this, but what I did is I created a series of BLG files that simulate the behavior of the different DRTs, because these changes here, let's set the tone map to low and the highlight roll-off to very soft, for example, can be roughly replicated with 1D and transforms within Baselight, and I used film grade for it. So we chose tone map low and highlight roll-off very soft. I need to bring them in the right order. The tone map should be applied before the highlight roll-off. So this is now the corrected version in Baselight, going from here to here. And this is the decode with these parameters from the raw SDK. And please note that I only used 1D film grade curves to replicate the behavior. Now let's examine the IPP2 raw decode settings compared to the legacy mode. Here I have a shot from the Red Monstro VistaVision in 8K resolution with a lot of fine details. And what I'm doing now is I'm applying a heavy zoom in. That's by the factor of 20. So we're zooming in basically this small area here at the legs of the climber. And what you will notice is that when I switch the decode settings to legacy, we will lose a little bit of the detail there and the sharpness for the finest details. So you can see that the red IPP2 decode maintains a little bit more of fine details in the image. Another benefit is here the handling of the highlights near the clipping point. This is the legacy decode. Also note here how the Luma waveform looks on that clipped light. In IPP2 mode, we are able to extend the highlights a little bit further compared to the legacy mode. Also see here that there's a little bit more of peak highlights near the clipping point. Okay, how does a visual effects round trip look like? In this case, I want to get rid of the second climber in that shot here, the one who walks behind. So I need to export that shot for the visual effects department. I'm selecting the shot in the timeline, go to the render page. First, I select my frame range that I want to render. I choose selected shots. Obviously, I can also select several shots in the timeline to export them. I want to do DPX plates. The first thing I'm going to change is from DPX 10-bit to DPX 16-bit file type. The reason for that is that modern log encodings like red log 3G10 can contain so much dynamic range that they lack a little bit of the precision when we encode them with 10 bits. So to be on the safe side and to not throw away any information that we got from the raw file, I suggest to use a 16-bit DPX format. For the render color space, as I said, I use red log 3G10. You should not use a linear encoding for DPX plates, because otherwise the information above diffuse white, so the values above 1.0 in linear, will be thrown away and clipped. For DPX visual effects round trips, using a scene referred log encoding color space is always the best practice. As a render format, I choose Ultra HD. All the other settings are good here. I set the metadata to shot time code and shot tape name, and also already preset the path where it should render to. Let's do OpenEXR plates. So I change the name of the render preset to EXR. Obviously, I will also change the file type to OpenEXR. For the compression, I will use one of the lossless ones, and I like the lossless wavelet compression because it gives me the smallest file sizes while still maintaining a lossless compression. The render color space, this is now important, needs to be set to a linear tone curve. In this case, for a red project, I will go with red linear, red white gamut RGB. OpenEXR files are really optimized for linear encodings. So I strongly suggest you not to render log color spaces into OpenEXR, otherwise you will really throw away a lot of the color precision of the file type. I will need to adjust the path here for the EXR plates. Alright, I think this is ready for render. Okay, let's examine the plates with Flux Manage. Here are the plates. Let's go with the DPX one first, and let's have a look at the file size. The shot is 4.8 gigabytes, and that's roughly double the size of the OpenEXR one. This is because of the lossless compression of OpenEXR. I will insert the DPX shot first, so I make sure that my cursor is on the first frame of the original shot, and what we notice is that the colors are already matching to the original, and this is because the input color space is set to unknown from Baselight, but as a fallback it will use the working color space of the shot, which is called the stack color space, and this is red log 3G10, which matches the actual color space of the file. If we import back the plates or the visual effects delivery, I still recommend to tag it correctly. So let's have a look at the delivery we got from the visual effects department, which I already prepared here. We can see here that for the DPX it goes similar than with inserting the plate. I will set the input color space correctly, and we see that the second climber is painted out. Let's move this a little bit above in the stack, and let's check how it goes with the EXR version. So first here I have a shot which has correct color space metadata in it about the color space of the EXR. And what we can see here is that Baselight reads the metadata correctly from the EXR file and inserts it with the correct input color space. But of course, all of us know that in real-world scenarios, we often have EXR files with missing color space metadata coming from visual effects departments. This is something that I prepared here as well. Same shot, but without the color space metadata. What we are noticing is that the luminance matches to the original shot, but the colors are off. What happens here? Baselight as a fallback selected CGI linear Rec 709 primaries as an input color space. The linear tone curve is correct. This is the recommended tone curve for all OpenEXR files, but the color primaries with 709 are off. So we need to manually set this to red linear red white gamut RGB. Now this shot matches as well to our reference. If you want to avoid to set all of these input color spaces manually on every visual effect shot that is coming into your project, we have a tool called Media Import Rules. Here what you can do is you can filter by file type, and in this case I added an additional criteria, which is visual effects must be somewhere in the path name or VFX. And for all shots that match these two criteria, I set the input color space to red linear red white gamut RGB, and additionally I add a visual effects category to the shot. That will make it easier in the management of the project later to identify visual effect shots. If I will now reinsert the shot with the missing metadata, you will see that it will have automatically the right input color space, and it also has the visual effects category already set as a strip. Of course, you can also apply these media import rules on existing timelines with the options down here. And another thing to note is that for raw footage, you can automate the always decode at max quality setting and the input strip caching as well here. And in this example, I set all R3D movies coming into that timeline to have both of these options checked. So that's it for today. See you next time.